Hello and welcome friends to my channel Effective Engineer. Now in this video we will see about the Chandrayaan-3 mission by ISRO. Now this is third lunar exploration mission by ISRO. As we all know, on 14 July 23 ISRO will launch the Chandrayaan-3 at 2:30 p.m. according to Indian Standard Time from Satish Dhawan Space Center, Sriharikota. Now rocket used in this mission will be LVM-3, that is Launch Vehicle Mark 3. It is a three-stage medium lift launch vehicle and it has higher payload capacity than GSLV, that is Geosynchronized Satellite Launch Vehicle. So in this video we will see about the background of this mission, the previous mission of Chandrayaan by the ISRO, the objectives of this mission and the design of Chandrayaan-3. So let us start. Now Chandrayaan-1, this was the first mission conducted by ISRO in 2008, operated until August 2009. The mission included the Lunar Orbiter and the Moon Impact Probe. Now it was intended to survey lunar surface to map chemical composition at the surface, three-dimensional topography, and to test the impact of probe on the surface of Moon for the future soft landing missions. But after almost a year, orbiter started experiencing some technical issues and stopped communicating, after which ISRO declared the mission was over. Now the Chandrayaan-2 mission. Now this was launched by ISRO in July 2019. The mission included orbiter, lander and rover. The objective of this mission were to demonstrate the ability of soft land, operate rover on lunar surface, study lunar topography, elemental abundance and signatures of water ice. However, the lander crashed and it deviated from its trajectory while attempting to land. So this mission also got failed. Now, why Moon South Pole is so special for us, that the landing we are doing on the Moon, the location is selected as a South Pole. So these are the reasons why the South Pole is so special for us. Now it craters, the South Pole craters have been untouched by sunlight for the billions of years, which offers an undisturbed record of solar system origin. Its permanently shadowed craters are estimated to hold nearly 100 million tons of water, and it has the traces of hydrogen, ammonia, methane, sodium, making it untapped source of essential resources. So NASA claims that the temperature at this south pole may be even up to minus 230 degrees Celsius. So maybe it contains the fossil records of hydrogen, water, ice and other volatiles from the early solar system. So these all reasons hold some clues to early life. So maybe due to this reason the south pole is so special for us, and we are going to land at the south pole of the moon. Now these are the objectives of Chandrayaan-3: getting safe land on the surface of moon, observing and demonstrating rover's capabilities on the moon, making scientific experiments on chemical and natural elements, soil, water, etc. available on the surface of moon to better understand the composition of moon. Now we'll see about the design of Chandrayaan-3. So now you can see in this figure. So these are the three components by which the Chandrayaan is made, that is lander, rover and propulsion module. So as you can see in this figure, this bottommost part is propulsion module, and this is a lander which has these four legs. Okay, so these legs are also made some more strength as compared to Chandrayaan 2, and the rover will be present in this lander. So after getting on the surface of moon, this door will get open of the lander, and rover will be out of the this lander, and it will do its work. So we will see in next slide. Okay, so these are the basically three components. So in this mission, Chandrayaan-3 is not using any type of orbiter, because the orbiter which we sent in the Chandrayaan-2 mission is still working. So in this mission there is no need of orbiter. So its propulsion module will act as a communication relay satellite. So in upcoming slides we will see all these components in detail. Now this is lander module, named as a Vikram. So you can see this is lander. Its weight is almost 1752 kg. Now it consists of four payloads. The payloads, in the sense, you can say like the machines or the sensors. So these are some machines or sensors, that is RAMBA, that is radio anatomy of moon, hypersensitive ionosphere and atmosphere. Now, this is basically to study the evolution of electronic density in lunar ionosphere, that is in the moon ionosphere. Now, the second one is CHASTE, that is Chandra's Surface Thermophysical Experiment, to measure the thermal conductivity and temperature. The third one is ILSA, that is Instrument for the Lunar Seismic Activity. Okay, to measure the seismicity around the landing site. So seismicity means the frequency, intensity, and the distribution of quake. So quake in the sense, on Earth we called it as earthquake. So on Moon it will be moonquake. To study the frequency, intensity of distribution of moonquake. Okay, and the last one is LP, that is Langmuir probe. Now it is to estimate, to calculate, we can say, plasma density and its variation. So these are the four payloads the lander is carrying with itself. Okay, now this second one is rover module, that is named as Pragyan. So in this figure you can see, this is lander and this is rover with wheels. Okay, so it will, after landing on the surface of moon, this rover will be out of the, you can say, lander, and further it will do its work. Okay, so its weight is very less, that is 26 kg. It consists of two payloads, that is APXX, that is alpha particle X-ray spectrometer, and LIBS, laser induced breakdown spectroscope. And these are used for the deriving elemental composition in vicinity of the landing site. Now this third one is propulsion model. You can see in this figure. Now its weight is about 2148 kg and consists of payload, that is shape. Okay, now shape is a spectropolarimeter of habitable planet Earth to study the spectral and polarimetric measurements of Earth from the lunar orbit. Okay, to just for the polarimetric measurements of Earth, we are using this shape. Now this propulsion model, after what we can say, after detaching this lander at particular distance from the moon, it will just rotate, it will revolve, you can say, around the moon, and do this work by the shape, you can say, machine or sensor. It will measure the polarimetric measurements of Earth from itself. Okay, so and the second, for which is propulsion model is used, that will be as a communication relay satellite. Okay, so it will do it both the work. First it will measure the polarimetric measurement of Earth, and second it will act as a communication relay satellite. So we will see what is communication relay satellite. So in this figure, as you can see, the lander and the rover on moon cannot pass their information to the ground station on Earth if it doesn't have the clear view of ground station. So just imagine that, suppose this is our ground station on Earth, and somewhere over here this is a moon. Okay, but moon lander and rover cannot have the clear view of this ground station on Earth. So in this case, the propulsion model, which is revolving around the moon, you can say, so what they will do is lander and rover will transmit their signals to the propulsion module, and then propulsion model will carry those signals, or you can say those data, to the ground station. So it will act as a bypass for the supply of information of data. Okay, so therefore communication relay satellite serves as a way to pass along information. So in this way, the whole design of Chandrayaan-3 is done, and all I have explained over here is the objectives of mission, the design of the mission. And I hope that this video was really helpful for you. So subscribe this channel, share this video. Thank you.